Hello everyone, welcome to the next lecture on the PY question series. Today we will discuss about residue theorems and the complex integration. We will cover all those questions from the GATE mathematics exam such that 1996 to 2023. Myself Dr. Harish Garg. You can simply follow my YouTube channel where there is a playlist of the CSR UGC net. The last we have discussed about the linear transformation complex integration from the CSR net last 12 years. In this lecture, we will see about the complex integration and the residue. We will cover more than 45 plus questions in this lecture related to the GATE mathematics from these years. Definitely, we will cover all those questions with the help of shortcut tricks. So first of all, let me quickly recall what is the residue and some shortcut tricks. The residue of the function f of z at the point pole is defined like here, where n is the number of the order of the pole. Secondly, if you want to find the pole by using this definition, or you can expand it with the coefficient of the 1 over z minus a in the Lorentz series. Another way, if you find all those poles or singularities, say a, b, c inside the contour c, then you can find the integration of this function f of z is 2 pi iota residue at the point a, residue at the point b, which is computed by here. Also, we know how we can compute this integration by using the Cauchy integral formula, and this is the nth derivative. One more important remark for you is, if f of z has a simple pole at z0 and g is my analytic function at the point z0, then the product of the residue of the product is nothing but, because this function is analytic at z0, we can compute the value of the g at the point z0 and the residue of the f at z0. What is the complex integration? As this is the Cauchy integral formula, and whenever the function is analytic, then the integration will be 0. Another important remark for the complex integration is the argument principle. Whenever there is a derivative of this, like if I say z raised to power 7 over z raised to power 8 plus 9, you can see the derivative of this is up here, upside. Then you can find the number of the poles of this f and the number of the zeros of this f. Then this is the argument principle. Now based on this mark, we can solve the 45 plus question in a very simple manner. Always remember, whenever there is a question related to the integration, you always draw the diagram first of all. Fine. So how you can draw the diagram? You can see x is my plus minus 1, y is my plus minus 1. So this is my 1, this is my minus 1, and here. Now what is the pole of this? If you find the value of this, it is minus 3 over 2. So minus 3 over 2 lies outside this feasible area. This is my feasible area. So since this lies outside, so therefore this integration will be 0. So the right answer is my C. Always draw the graph, look at the point which lies inside. If those points lies outside, the integration will be 0. Look at the second one. Firstly, because there is no reason is given to you, so we can see the denominator part is 0. What is the meaning of that? Z is equal to 0 is order 8. Fine, this is my pole. Then your target is to find this. So it's a 8, it's a n. If it is order of the n, then it will be n minus 1 factorial, n minus 1th derivative of the remaining part. So it's a 7 factorial, and 7th factorial of z raised to power 7 into this part. So this is my sine z over z raised to power 8. So clearly say this will be cancelled out at the point 0. So can you find the 7th derivative of the sine? So if you look about here, you can see the first derivative is cos, second derivative is minus sine, third is cos, then minus sine, then cos. Cos is a cos is a minus sine, it's a minus cos, it's a minus plus sine, it's a cos, it's a minus sine, it's a f third, it's a fourth, it's a fifth, it's a sixth, and it's a minus here. This is 7th derivative. So what is the derivative at the point z is equal to 0? Cos 0 is 1, so its value is my minus 1 over 7 factorial is the right answer of this problem. The residue of this at any of its pole. So we can write the cot is nothing but cos z over sin z. Fine. So the pole is obtained by taking sin z is 0. So because it said at any, so I can say z is my 0. Fine. It's my single pole. So what is the residue of this? So it is 1 over 0 factorial. That is the first. That is a single pole. So you can simply take the value of this at z into cos z over sin z. You can find the value of this at z is equal to 0. Now clearly say it's a 0 over 0. So I can apply the L'Hopital rule. It's a sin this plus cos z divided by cos z. So what is the derivative? What is the value at z is equal to 0? Cos 0 is 1. This is 0. Cos 0 is 1. So the right answer is my 1 is the correct answer of this problem. Now you can see this integration and mode of z is 2. That means it's a circle with center is 0. Radius is my 2. Fine. Then you can find the pole of this. So clearly says pole is my -1, -1 and -1 lies inside it. So what is the answer of this is 2 pi iota. This is a -1 2 times. So I can return this as 2 minus 1 factorial. That's a 1 factorial. First derivative of the remaining part, that is e raised to power z. Fine. If it's a 2, then you have to take the first derivative of this. So what is the right answer of this? 2 pi iota e raised to power z at z is -1. So the right answer is 2 pi iota e raised to power -1 is the right answer of the problem. Again you can see a circle with center is 0, radius is my 3. It is given to you. Then you can find this denominator as z minus 4 and z minus 3. So you can see 2 and 4 are my pole. Now clearly says the 4 is lies outside, so there is no pole, and 2 is lies inside it. So what you can do is a single pole. So I can return as a 2 pi iota. Apart from this, I can substitute z is equal to 2 in these functions. So what is that? The numerator part will be sine of 4 pi plus cos of 4 pi divided by 2 minus 4. So sine 4 pi is a 0, cos 4 pi is 1. So 1 over minus 2 into 2 pi iota is the right answer of this problem. Minus pi iota, C is my right answer. Now again it's a circle with center is 0, radius is my 4. This is 4, this is my -4. Now can you find the pole of this? So poles are my +1, -1. So +1 lies inside, -1 lies inside. So I can return this function as z -1 and z plus 1. So which is nothing but 2 pi iota times when z is equal to -1. So I can skip this portion and substitute the values apart from here. So it is my minus of 2 plus when z is equal to +1, I can find the pole corresponding to this. It will be 1 over z plus 1. So I can substitute the value of the z is my here. So right answer is 0 is the right answer of this problem. You can see within a couple of seconds you can get your answer. Make sure you have to draw this feasible graph. Let T is the circle enclosing the origin and the counterclockwise. Is there any circle? So radius is not given to you. I can assume the radius as say 1. Because if the radius is not given to you, then you can find its radius as 1 minus 1. Now what is the pole of this? You can clearly say the pole is my 0, 0. It's a double pole and it lies inside this region. So what is the answer of this? 2 pi iota is a double pole, so it's a 1 factorial. First derivative of the remaining part, cos of z at the point z is equal to 0. So you clearly see what is the derivative of the cos z. It's a minus sine z. What is the value at z is equal to 0? Sine 0 is 0. So the right answer is my B is the correct answer of this problem. Look at this another one, which is this is ellipse. Fine. Now that's very simple. Again you have a cot pi z over z minus iota square. I can written this cot as cos over sine pi z into z minus iota square. So which is a ellipse, so the axis will be like of this. Then the pole of this will be pi z will be my n pi and it will be my iota times iota. Fine. So if this will be here, then z will be my n. Fine. And from here z will be my. Now we can see whether it satisfied it or not. So when it will be here, x is 0, y is 1. Is it satisfied? Remember, it's not equality. Is it satisfied inside this curve? That means 4x square plus y square is less than equal to 2. Is it satisfied? Yes, because 1 is less than 2. So it's satisfied. From here, z is equal to n means x is equal to n and imaginary part will be 0. So what is the value of the n? From here n will be 0, n is 1, 2, 3 and so on. So if I take n is my 0, is it satisfied? Yes. So it means z is 0 is also the pole. Z is equal to 1. When z is equal to 1, it means x is 1, it is not satisfied. So that my poles are 0, iota and iota. Then you have to integrate this portion. So what you can do, you can find the residues corresponding to this. So 2 pi iota times is a 0, it's a single order. Okay, so we can find its z into this answer. So I can written this as a cot pi z divided by z minus iota square plus, it's a double order, so I can written as a 1 factorial d by dz of, this is a double order, it is already written, so I can return the remaining part. Fine. This is a value at the point z is equal to iota. This is a value at the point z is equal to 0. Now clearly say, firstly I can find it is a cot means derivative is cosecant square pi of z. Fine. So what is the cosecant square of at z is equal to iota? So it is my minus pi. I can written as a sine square pi of iota. I can written as a hyperbolic. So we all know what is the sine of iota x. It is sine hyperbolic x. So this part will be my minus pi sine hyperbolic square of pi. Fine. Now we can see here what is the z of 0. So if I substitute here, cot of 0 will be infinity. So 0 into infinity. So we can apply the L'Hopital rule. So can you find the derivative of this? I can written this portion as if I substitute 0, it is my cos is iota square, is minus 1 is outside. So I can written this as cos pi z over sine pi z. Now what is the value at z is equal to 0? I can apply the L'Hopital rule. So pi cos of pi z minus, I can written outside, it's a minus z sine pi z into pi minus plus cos of pi z. So what you do at z is equal to 0, this value will be 1, this value will be 0, it is 1, so 1 over, so minus 1 over pi minus of this into 2 pi iota is the, so it's a 0 is a cancel, 2 pi is a cancel, minus pi over I and it should be minus. Fine. So this option is cancelled. So C is my right answer of this problem. Okay, look at this another one. R is given to be as 2 plus 4 cos theta. So I can written this number as R minus 2. What is the modulus of this? It is a less than or equal to 4. It means it's a circle, center is 2, radius is, I can written this number as 2 square. So it is my circle of this one. Fine. Now look at that, 4I1. What is the pole? Pole is Z is equal to 1. So Z is 1 is lies here. So which is lies inside? So what is the right answer of this? 2 pi iota into, substitute the skip the Z minus 1, so there is only 1. Similarly for the I2, what is my pole? Pole is my 3, which also lies inside it. So therefore I2 will be my 2 pi iota times If I skip the Z3, it is only my 1. So you can see both the numbers are my same is the right answer of this problem. Now you can see that it's a circle with center 0, radius 1. Fine. Now what is Z plus 2? What is that? Z plus 2 is 0. Z will be my minus of 2, which lies outside this circle. So what is the integration is 0 is the right answer. What is the meaning of the 0? Because the real part of the Z is my x. So this part will be my here, which is outside the pole, outside this circle. So it means the answer is my 0. That means this function is my analytic over this domain. Okay, look at this one. How you can solve that? A very simple tips I can give you. Whenever there is an integration of 0 to 2 pi dx over a plus b cos theta, or whenever there is an integration of 2 to pi dx of a plus b sin theta, remember it, whatever the result is there, the answer will be always be this divided by a square minus b square. Fine. A is my constant, b is the coefficient of the cos and sine. So if you look about that, what is the answer of this? 2 pi a square 13 square, whether it's a plus or it's a minus, that's the same thing. Whether it's a plus or minus, it's a 5 here. So what is the right answer of this? It's a 144, it's a 12. So right answer is pi over 6 is the right answer. No need to solve this integration, just remember this formula or the simple shortcut tricks, so that you can write it quickly whenever it's a sine or cosine, whether it's a positive or negative is the right answer. I hope you can like my video, as you can see a lot of the shortcut tricks in here. Okay, what is the principal value of this? Sometimes it is called as the Cauchy principal value. Oh, very simple. Remember this shortcut tricks for you. It's a 2 pi iota. Find the residue of the function at of z whenever imaginary part of z is my strictly greater than 0, plus pi of iota residue of f of z when imaginary part of z will be 0. Fine. So firstly I can write this number in terms of complex part. So it is 0 e raised to power iota z divided by 1 plus z square. Fine. So what is the meaning of that? I have to it's a cosine. I have to make the real part of this. Now the rest of the thing is very simple. What is the pole of this? Pole is my iota and minus iota. So what is the imaginary part of this? Imaginary part of this is my plus 1, which is greater than 0. Is there any imaginary part which is 0? No. So this part will be my 0. So what is that? I have to find the residue of the f of z over, I have to find over z is iota. So I can return this function as this z plus iota, z minus iota. So what is that? I can substitute this value here, 2 pi iota times e raised to power iota square over 2 iota. So what is that? 2 iota will be cancelled. It's a pi e raised to power minus 1. Then we need a real component, so we can equate the real component, although it is purely a real number. So the right answer is pi over e is the correct answer of the problem. Remember, this is the simplest way you can solve any of the Cauchy problem, Cauchy principal value of the integration. Make sure you have to check whether it's a real. If it is a sine, if instead of this is a sine, we can find the imaginary component. Then what is the imaginary component is 0. So then 0 will be the right answer. Okay, look at this another one. Gamma is the simple closed curve in the complex. Okay, radius is not given to you. So that means this is my R. Fine. Then firstly we can find the pole of this. The pole will be z is equal to 0 and corresponding to this is 1 or minus 1. Now clearly says the radius is not given to you. Fine. If I consider a simple closed curve in the complex, okay, if I consider the radius is say 0.3, then definitely this will be my curve. Okay, center is also not given. Center is also not given. Center is also not given. Okay, what is that is mean? Then the set of the possible value of this. So if I consider like of this, because center is not given, so I can say this is my 1 for example, or I can center is my 12 and this, what is happen? This is my 12, this is 11 and this is my 13. Fine. Then clearly says 0, 1 and minus 1. 0, 1, minus 1. It lies outside. Then the integration will be 0. But if I consider the circle of radius this 1 or minus 1, then all the point lies inside it. Or if I consider the radius is my half this, then only the point 0 lies inside it. That's why they are not talking about the exact answer. So what will happen if I take z is equal to 0? The answer will be, I can factorize it as, because the coefficient of the z square is a negative, I have to make the coefficient as a positive. So I can take negative as a common. Make sure the coefficient of the z should be positive. Fine. So what is the value? What is the residue? Or there is no need of the residue. You can see at the pole z is equal to 0. What is the answer of this? 2 pi iota times, I can substitute the value of the z 0 everywhere apart from the here. So it's a 0 plus 1, 0 minus 1. So the right answer is 2 pi iota. So this answer does not contain the 2 pi iota. It's a plus, it's a both. It again does not contain. Now we will see whether plus or minus both. Now at z is equal to 1. At z is equal to 1 means I can find the values corresponding to this. So I can substitute z is equal to 1 apart from this term. So it's a minus 1 over 1 and 1 plus 1 is 2. So clearly say it's a minus of pi iota, but he said plus of pi iota. Right answer is my C is the correct option. Okay, look at this one. Okay, that's again a very simple. I can write this function as firstly of this iota, this one, fine, or I can return this function this into e raised to power minus iota, fine. I can easily write this part like of this. Now how you can solve this integration? Can you think about that? Very simple. It's a 0 to 2 pi. Now I can take z is e raised to power iota theta. So we need a d of z. So what is the theta? It is 1 over iota times log of z. So what is the d of theta? 1 over iota times of this one. So this integration becomes my e raised to power z. This value will be my 1 over z. D theta will be my 1 over iota times of this. So this is my 1 over iota is outside, e raised to power z over z square. Now since it's a 0 to pi and this is my, so circle is my 1. Now it's a circle, center is 0, radius is my 1. Fine. Now look at the pole. What is the pole of this? Pole is my 0, 0, both lies inside it. So what is the right answer of this? 1 over this into 2 pi iota. It's a pole of order 2. So it's a 1 factorial. First derivative of the numerator part at the point z is equal to 0. So what is the first derivative of this? E raised to power z. At the point 0 is a 1. So it is cancelled. So right answer is my 2 pi is the right answer of this problem. A very simple target. You have to just simply evaluate this part and you'll get answers simply. Okay, look at this one. F is the analytical function, then the value of this integration is equal to. Very simple. Look at that. f is any analytical function. So if I simply choose f is a constant, clearly says this is my analytic function. So what is the integration of this? 0 to 2 pi. F is my 1, so it's a cos of t. So what is the integration of this? Sine 2 pi minus is 0. So it's a f of 0, 1. It's a 2 pi cancel. It's a f dash. What is the f dash is? F dash is 0. So it may be answer, it may be. So this option is cancelled. Now I can think about any of the other function. Let's say f is my z, which is again an analytic function. Fine. So what is the integration of this? 0 to 2 pi e raised to power iota t. F of z is my z. It is my cos of z. Fine. So what is that? How you can integrate this? Is a 2 pi. I can integrate. What is the cos of z? I can written as e raised to power iota t, e raised to power minus iota t into t. It's a z. Sorry, it's a t. So here. Now if you open this bracket, it is my e raised to power 2 iota t over 2 plus integration of half of dt. So 0 to 2 pi. So it is my plus pi. This integration will be 1 over 4 iota is outside. E raised to power 4 pi iota minus 1. This is my 0. Right answer is my pi. Look at that. This option is cancelled. What is the f dash? If my f is here, so what is the value of the f dash of 0? 1. So this is my 2 pi. Is a cancel. This value is my pi. Is the right answer of this problem. This is the first method. You can take a counter examples, okay, and then discard the option. There is one more method. How you can solve that? Instead of thinking of this, what I can do is I can simply take this cos of t as e raised to power this e raised to power minus divided by 2. Fine. Then I can simply take z is my e raised to power iota t. Then what will be my dt? It is 1 over iota z into dz, and this limit will goes to the circle 1. So this is my f of z, this is my z, this is my 1 over z, and dt will be my 1 over iota z. Now if I open this bracket, 1 over 2 iota I can take as outside. So this is f of z into dz plus I can take integration f of z over z square. Fine. Now since f is my analytic function, so the integration will be 0. It has a pole 0, 0. This is a circle over the radius 0, center 0, radius 1. So what is the right answer of this? Into 2 pi iota is a pole of double, so it's a 1 factorial. This value of this at the point z is equal to 0. So it's a 2 iota cancel, it's a pi. First derivative is f dash at the point 0. So f of this is the right answer of this problem. So it's on you whether you want to take calculation part, but I always recommended you because f is an analytical function. It can be any of the kind of the analytical function. You can start with a constant. If options are not cancelled, then take as a z, or you may take as a sine of z or any of the other functions as well. But make sure that is to be the analytic function. Okay, look at this another one again, which is a circle with the center is 3 iota. What is the coordinate of the 3 iota? I can written this as 0, 3. So this is my 0, 3. Radius is my 2. So it starts from, this is my 3, radius is 2. So it's a 1, 2, 5. It's a 1, this is my 5. So can you find the pole of this? I can written this is as a 2 iota, z minus 2 iota. So what is the pole of this? Poles are my 2 iota and minus of 2 iota. What is the coordinate of this is 0, 2. 0, 2 lies here. What is the coordinate of this is 0, minus of 2. 0, minus 2 lies outside them. So the only pole is my here. Fine. So what is the right answer of this? I can write it as a 2 pi iota times, I can substitute the value of the 2 iota here, 1 over this one. So what is the right answer of this? Pi over 2 is the right answer of this problem. Always draw the graphical representation, look at the pole, whatever the pole lies inside it, we can find the coordinates and the residue and you can get your answer. I hope you can like my video. Okay, look at this one. F is a polynomial. Okay, again, what is that? Center is my iota. I can written as 0 plus iota. So this is my 0 comma 1. Radius is my 2. So radius is my 2. This is my 0 comma 1. So when it will be radius is, it start from the -1 to 3. Fine. This is my 3. This is my -1. Then now you can find the pole of this. Pole will be my iota. Order is my 15. Fine. So where is the iota? Iota lies here. It lies all in this pole. So what is the right answer of this? 2 pi iota times is a pole's order 15. So it's a 14th derivative of the function f of z at the point z is iota. Fine. Now clearly says f is a polynomial of degree 15. So can you easily find the 14th derivative? Yes, I think you all know, like if I say this is my z15, z14, z13 and so on. So clearly says when you take the 14th derivative, this value will be 0, this value will be 0, this value will be 0 and so on. What is the 14th derivative of this? It is nothing but my 15 factorial into z. What is the 14th factorial of, what is the nth factorial, what is the nth derivative of this? It's a n factorial. So you can see it is my 14 factorial. So I can substitute this value here, 2 pi iota 1 over 14 factorial. What is that? It's a 15 factorial at the point z is iota plus 14 factorial. Now what is the right answer? 14 factorial will be cancelled out. 2 pi iota, it's my 14, sorry, it's a 15 iota plus 1 is the right answer. This option is cancelled. It's a 4, but we need a 2 pi. It's a cancel. Only A is my correct answer of this problem. Okay, look at this another one. The residue, you have to find the residue at the upper when z is equal to y is positive. Y is positive means we have working on here. Can you find the pole of this? Pole is my 0 and corresponding this is iota and minus iota. You can see here y is my less than 0, y is -1, so it is cancelled out. So we have to consider only 2, 1. Moreover, z is equal to 0. What is the value of the y is 0, but here we need a y strictly greater than 0, so it is also cancelled. We need only to be here. So I can return this function as z plus iota, z minus iota. Now since corresponding to z is equal to iota, that means for here, so I can, it is a single pole, so I can substitute the value of z is equal to iota in the remaining portion, because we need a residue, so there is no need to multiply by 2 pi iota. So that is a simple of this, iota times iota plus, so what is that, e raised to power -1, it is my 2 iota square, so it is a -1 over 2e is my -1 over 2e. A is the correct answer of this problem. Very simple, you just look at the coordinates, y is equal to greater than 0, that means we are looking for this portion, first and second one. Okay, look at now again, it's the Cauchy principal residue. So I can return this as e raised to power iota z divided by z into 1 plus z square. Now since it's a sign, so we need a imaginary part. What is the shortcut tricks? As I told you, it's a 2 pi iota. We can find the residue of the f of z when imaginary part of the z is a greater than 0 plus iota times pi residue of f of z when the imaginary part is equal to 0. So can you find the pole of this? What is the pole corresponding to 0? It is my iota, it is my minus iota. What is the y is equal to 0? Greater than 0. Here y is equal to 0 is my this. So I can written this function as z plus iota, z minus iota. Now I can substitute here 2 pi iota into, what is the residue of this when y is equal to 0? Y is 0 is corresponding to here because y is equal to 1. So y is equal to 0, that means here I can substitute everywhere the value of iota. So it is a iota square divided by iota into 2 iota plus pi iota. What is the value of this y0? That means here I can substitute everywhere the value of the z is 0 apart from this. So e raised to power 0, it is my iota and minus iota. So what is the right answer of this? It is my e raised to power minus 1, it's a minus of 2, e raised to power 0 is 1, it is my plus 1. So what is that? It is minus pi iota over e plus pi iota. So what is that? I can written in the terms of pi. I can take a pi iota is not be there. Why? Is it something? Okay, fine. So I can take a pi iota as a common, 1 minus 1 over e. Now since we have a sign, so that means we need a imaginary component. So we can equate the imaginary component from this. What is the imaginary component? Pi times 1 minus e is the imaginary. So that's the right answer of this. So you can see B is the right answer because we need a sign. So sign will be happening only when it's a imaginary component. So imaginary part of this is the right answer. If somebody asks you find the principal value of the cos z, x into 1 plus x square. So since cos will be corresponding to the real component, but here there is no real, I can written this as a 0 plus. So this is my cos component, that's the answer of this, and this is my corresponding to the sine term. Okay, look at this another one. Again the integration is given and the circle center is 0, radius 3 minus 3, center is 0. Then we can find the pole. Pole is my 1, pole is my 2. What is the pole of the f of z? Because it's a sine and cosine, it can never goes to the infinity. Remember, whenever there is a function of the f and g, what is the pole? Pole means whenever g of z goes to the 0 and f of z goes to the infinity. But here f of z is my this, which is never goes to the infinity. So that means the pole is only from the denominator. 1 is lies here, fine. 2 is lies here, fine. Now what is that? Corresponding to z is equal to 1. I can substitute the value everywhere apart from this 1. So it is a 1 minus 2. What is the value corresponding to z is equal to 2? It is f of 2 over 2 minus 1. So the final answer will be, I can add that into 2 pi iota. So what is the value of the f of 1? If I substitute here, sine pi by 2 is 1, cos pi by 2 is a 0 over minus 1. It's a minus 1. F of 2, sine of pi is a 0, cos of pi will be minus 1 over plus 1. It's a minus 1. So what is the right answer of this? 2 pi iota minus 1 plus of minus 1. It's a minus 4 pi iota is the right answer of this problem. Once you can draw the feasible area, you can solve the answer within a 15 seconds. Now you can see find the residue when z is equal to 2. Firstly, because the coefficient of the z is negative, so I have to make the coefficient of the z as a positive. Fine. So what you can do, you can simply write the denominator part, that is a cube minus b cube, which is a minus b, a square plus ab plus b square. So it's a square plus ab plus b square. Now you have to find only the residue at z is equal to 2, that means here. So what is the value of this? I can substitute the value of the z at here. So it's a minus of 2, 4 plus 4 plus 4. So minus 2 over 12 minus 1 over 6 is the right answer of this problem. Always remember student, you have to make the coefficient of the z is always a positive. Highest power of the z make a positive. Otherwise you will get answer as plus 1 by 6. That's a wrong option. Okay, now again it's a Cauchy principal value. Fine. So firstly again I can make the value of the z as a highest power of the z as a positive, minus 8, which is written as z minus 2, z minus 2 omega, z minus 2 omega square. So what is the Cauchy principal value? 2 pi iota residue of the function when the imaginary component is strictly greater than 0 plus pi iota residue of the function when the value of the y, that is imaginary part of this, y is nothing but imaginary part of the z is my 0. So can you find the imaginary part of 0 here? So you can see the poles are my 2 omega square. What is the value of the y at here? Is a 0. So this is the value corresponding to this. What is omega? We all know omega is my this. Fine. And omega square is my of this. So can you say for what value of the y is greater? It's a 2 omega. So what is the value of the 2 omega is? I can multiply by 2. 2 omega square is I can multiply by. So when the value of the y is positive, so this is the value. It means there is a no component. So this is the value when y is greater than 0. So now you can substitute it. So it is my 2 pi iota. This is the value corresponding to the 2 omega. I can substitute here apart from 2 omega. So it is my 2 omega divided by 2 omega minus of 2 into 2 omega minus 2 omega square plus I can substitute here corresponding to the y is equal to 0. Y is equal to 0 means that is a z is equal to 2. So when z is equal to 2, I can substitute everywhere apart from this part. It's a minus of 2, 2 minus 2 omega and 2 minus 2 omega square. Fine. Now you have to just simply solve this expression. How you can solve? I can take omega as a cancel. It's a 2 pi iota minus of 2. I can take 2 as a common, omega minus 1, or okay, that's fine. Then omega will be cancelled. 2 as a common is a 4, 1 minus omega. Fine. I can firstly solve this part. So minus 2 minus 4 is a cancel, minus pi iota, it will be 1 minus omega whole square. Fine. I can take minus as a common. Fine. This is the first way. Now plus I can take as 2 as a common, 1 as a common, or otherwise this is the value corresponding to z is 2. I already computed this value as my minus 1 over 6. You can see this is the same value. This is the residue at z is equal to minus 1 over 6. So it is my pi iota minus 1 over 6. It is a minus pi iota over 6. So I can take pi iota common. It is 1 over 1 plus omega square minus 2 omega minus 1 over 6. Now I think you can easily solve this expression. Otherwise we can solve this expression. Otherwise there is one easiest way also, in order, because the calculation is lengthier. So what you can do is, instead of this I can solve from here. So how you can solve this? I can found the firstly I can found the residue when z is equal to 2 omega. Fine. That is of this portion. So what is that? I can take the limit z approaches 2 omega, z minus here into function. Function is my this value. Fine. Now you can substitute. Now clearly say it's a 0 by 0 form, so I can apply the L'Hopital rule. That will take a very less second. You can solve it easily. So what is that? It is my this numerator portion will be my 2 omega z minus z square. If I take that derivative, it is my 2 omega minus of 2z. Now clearly says when z goes to the 2 omega, it is not 0 by 0 form. So now you can easily substitute its value. So 2 omega minus 4 omega, it is my 412 omega square. So what is that? 1 omega will be cancelled. It is a minus 2 omega minus 1 over 6 omega. Or I can multiply this as omega square. It's 6. Why? Because we all know omega cube is always 1. So therefore this value will be my 2 pi iota times minus omega square over 6. Similarly, I can find this value, residue of the f of z, which is nothing but limit z approaches y is equal to 0 means z is 2. When you take the limit, then you have to subtract like here. So it is minus z over z cube minus 8. Again it's a 0 by 0 form, so I can apply the L'Hopital rule. It is my derivative, it's a 2 minus 2z. So if I substitute the limit as 2, so it is a 4 minus of 2 is a 12, is a minus 1 over 6. So this answer is minus pi iota over 6. So pi iota over 6 I can take as a common. So what is that? Pi iota 6 as a common, minus pi iota I common, plus of 1. So what is the 2 omega square? As I told you, omega square is this over 2. So 2 will be cancelled. 1. What is that? 2 omega square plus 1? It's a minus root 3 iota into minus pi iota by 6. So minus minus plus, iota square is a negative, minus pi over 6 root 3 is the minus pi over 6 root 3 is the right answer of the problem. So that's a simple little bit calculation, but it's on you whether you want to take the limit or you want to take as a simple derivative rule. Okay, look at this another one. F is an analytical function except at the simple pole of this. What does it mean? Do you understand what does it mean? It means it's a simple pole. Simple pole means at z is equal to 0. So this is here and the power is 1. And g is the analytic function. So I can consider this function as my here. Fine. Then the residue of this function will be here. Now very simple. I think there is no need to solve. Okay. Firstly, what is the residue of f of z at z is equal to 0? So what is that? Z is equal to 0 is a pole. So how you can do? It's a single pole. So what is I can substitute this value in this numerator. So this denominator part is my g of 0. Now what is the fz into here? It is my this over z into g of z, because g is my analytic function. So what is my pole? Pole is again z is equal to 0. So how you can find the residue of this function at z is equal to 0? I can substitute this value here. So it is g of 0, g of 0. So this is g of 0, g of 0. So this value will be cancelled out. G of 0 is my right answer of this problem. Now g of 0 is the right answer. Otherwise, if you remember that in the starting I have gave you one tips. If f is an analytic, f has a pole at the point z0, g is my analytic function. Fine. Then what is the residue of fz into dz? So it is nothing but g of z0 residue of f at the point. This is I gave you in the starting tips. So if you compare them, z0 is my 0. So this is my g of 0. This is my residue of the f at the point z0, which is the symbol of this. I can divide them, which is nothing but g of 0. If you remember my shortcut tricks earlier, then you can get your answer in a 15 second. Otherwise 15 to 20 second again you can get your answer. Okay, look at this another one. The residue of the pole is equal to 1. What is given to you? It means it is given that residue of the F at its pole is 1. What is the pole is? Z is equal to minus 1 and is of the double pole. Z is equal to minus 1 is the double pole. So what is the meaning of the double pole? It's a 1 factorial first derivative of this numerator part, or apart from this, that is my z square plus alpha z at z is equal to minus 1. So what is the right answer of this? If you take the derivative, 2z plus alpha at z is minus 1 is there. So minus 2 plus alpha is 1, alpha will be my 3 is the right answer of the problem. Fine, this is a GATE 2012 list. Now again, which is similar to this, which is a consecutive questions. For the value of the alpha obtained in this, we have obtained the value of the alpha as a 3. The function is a not conformal. What is the meaning of the not conformal? The function g, it means the value of dz is my 0. That's the meaning of this. So what is the derivative of the g? G is my here. So what is the derivative of the sine hyperbolic is the cos hyperbolic z minus pi over 2 alpha. The value of the alpha obtained as a 3. So this is my 6. Fine. Now when the cos hyperbolic will be 0, when this angle will be, yes, do you remember what is the value of the cos hyperbolic? It is my pi over 2 iota. So can you find the value of the z from this? It's a pi over 6 plus pi over 2 iota. So now you can simplify it. Everywhere is pi over 6 is the LCM. It's a 1 plus 3 iota. So A is the right answer of this problem. Remember, whenever there is a non-conformal, you can take a derivative as a 0. Okay, look at this another one. This is given is a triangle, so we have to write the triangle. What is the iota? What is the coordinate of the iota is 0, 1. So this is my 0, 1. This is my x is negative, minus y is also negative. So this is the coordinate of minus 1 minus iota by 2. This is my x is positive, y is again negative. So that's in the same line of this. This is the coordinate of 1 minus iota by 2. And he said it's a triangle. So this is the triangle. Fine. Then the integration becomes in the anti-clockwise. What is the value of this a? Where is the a? Okay, fine. Very simple. Can you find the pole of this? Pole of this is my 2. And where is the 2? 2, 0. This value is my 1, root 2. So 2 is lies here. Fine, which is lies outside this region. So the answer of this is part is 0. What is the pole of this? The pole of this is my 0 and 0 is here. So it means I can written this portion a minus 2 square over z of this plus the integration of the 4. So this is 4 is a constant. Constant is my analytical function. So the integration of this is my 0. That's over. Fine. Now it's a 0. So I can written this as minus 2 pi iota. Z is equal to 0 is a single pole. I can substitute the value of the z 0 everywhere at here because there is no z involved. So I can return this number as this number. So what is that? 2 cancel out. So what will happen is a minus 2 square is 2 over minus iota. I can multiply this is a plus. It will be my 2 iota. Now look at the option. We can see 1 plus iota. If I substitute here 1 plus iota minus of 2, it is iota minus 1 square. If I open this, it's a plus 2 iota, but you get a minus b whole square. It's a cancel out. If I take a 2 plus iota, then it is only iota square. It is also cancel. If I take 3, so it is a 1 plus iota square. Yes, it is a correct option. You can see it's a satisfied. Can I 4 plus iota? If I take a 4 plus iota, it is my 2 plus iota square, which is not equal to 2 iota. So the right answer is only C is the correct option. Let is a contour, center is 0, radius is my 2. Fine. Then the integration of this portion, z e raised to power 3 over z into dz. Now we have to find the pole. Fine. What is the pole? Because the denominator is nothing, but the function becomes infinity when z is equal to 0, because 3 over 0 is the infinity. So it means it has a pole of z is equal to 0. Then the value, and 0 lies inside it. How you can solve that? There are the two ways. Either you can take the limit as z into 0 of this complete portion. Fine. Or because it's exponential nature, so I can equate the coefficient of 1 over z minus pole is my 0. I can find the coefficient of z minus 0. So that's on your choice. So let me firstly, this is quite easy because I can open this. What is the exponential part? 1 plus x square into 2 factorial plus so on. Fine. So what is the coefficient of the 1 over z? This is the coefficient of the 1 over z. It's a 9 over 2 factorial. Fine. So what is the 9 of the 2 factorial is 9 over 2. So right answer is, value of the integration is, this is my residue. Fine. So that 2 pi iota into residue. So 9 pi iota is the right answer of this problem. Otherwise, again you can see it's a 0 into infinity form. Fine. If you take z is 0, then you have to write this function as 1 over z square. Then it's a infinity over infinity form. Apply the L'Hopital rule, and then again you will get the same as of 9 pi iota square. Okay, let u is the real value harmonic function of the C. Define the function g such that here which of the following statement is true. Look at that. Options are depends only on the g, but u is a real function, but answer is not dependent on the g. So can you take any of the harmonic function? What is the harmonic function is? uxx plus uyy must be 0. So I can simply take a constant function. It satisfied this property. So what is the integration of this portion? This value is my 1. You can see. You have to just read the statement very carefully because the answer is not dependent on the u. So I can take any harmonic function as a 1. So what is the right answer of this? The integration of this will be my here. Fine. So this will be my 0. So what is that? 0. So it means g is my 0. Fine. Now look at that. Is a harmonic? Yes, because gxx plus gyy will be 0, satisfied. So g is a harmonic. It's a not harmonic, cancel out. Neither harmonic, cancel out. So g is a harmonic. Is a polynomial? Yes, because 0 is a constant and constant is always represented as a polynomial. So this is a harmonic plus polynomial both. So A is the right answer. You can see that how long you can see the function is very complex, but you can solve it in a very quickly manner. Okay, look at this another one. Omega is all those components such that y is my greater than 0. Again, my domain is strictly greater than 0, this portion. C is here, we can write the graph. X is my minus 1, y is my 2. Final point is x is plus 1, y is my 2. This one. Fine. A to B. Then the integration of this. Very simple. I can, because the degree is same, so you have to divide it. I can return this portion as of this one. Fine. How you can do? I can return this as a 2 minus 1 plus z. Fine. Now clearly says this 2 into dz minus 1 over here. Fine. Now since this, what is the equation of because in this case this value is my 2. So on this case y is my fix, while x varies from -1 to +1. So what is the value of the z? It is x plus 2 iota. This is the equation of x plus 2 iota. So I can simply change its integration. So what is that? 2 into dx. The limit of the x is -1 to +1. -1 to, what is the x? Z is my here. So if I substitute this value, this, it's a 1 plus 2 iota plus x of dx. So what is that? It's a +4 minus, what is the integration of this is log, or because the answer is written the ln, so I can return this is my ln of 1 plus 2 iota plus x -1 to, it's a +4, so this option is cancelled out. So what is that? It's a 4 minus ln. If I substitute 1, it's a 2 plus this, divide, because it's a ln minus, I can substitute here as a 2 iota. So what is that? 4 minus ln, 2 will be cancelled out, 1 plus iota over this. I can rationalize it. It is my ln. It's a, if I rationalize this, it's a iota, and iota is a -1. It's my 1 minus iota. Now it's written in the log form. I can return this is my exponential. Polar form is this minus pi over 4. So what is that? What is the ln of 2? Is a 1 minus of this. It's a minus iota, sorry, plus pi iota over 4. So 4 minus half ln 2 plus pi iota by 2 is a plus, is a 2, but it's need a 4. Is the right answer of this problem is A is the right answer. Okay, look at this another one. If A is the any complex number such that this property, then again you can see A is the any complex number. So what is the easiest way you can take? You can take A is my this, but it is not satisfied this property. I can take A is my strictly less than 1. So I can take as A is my half, which satisfied. But the most easiest way I can take A is my 0. It satisfied this property. So this integration becomes my 1 over pi dz over mod z square. So now if I take A is 0, that means center is, okay, this. Now what is that? This is center is 0, radius is my 1. So what is that? What is the integration of this denominator part? This part is my 1. Fine, because mod of z is my 1 square is 1 over this circle C. So what is that? This is the length. So what is the length of this circle? It's a 2 pi r. R is my 1. So 2 pi will be, pi and pi will be cancelled out. 2 is my right answer of this problem. Always read the statement carefully. Here A is my unknown, but it can be any real number with any complex number which satisfies this property. You may take this, or the best way is you can take A is my 0, so that your calculation will be very small. Okay, now again this is a circle. Center is my iota, that means 0, 1. This is my 0, 1. Radius is my 2, so this is my 1, this is my 2, and here is my 3. Fine. This is my circle of -1, 0, 1, and this is my 3. Then I can return this denominator portion as z plus 2 iota, z minus 2 iota. I can found the pole. What is the pole of this? It's a plus of 2 iota minus of 2 iota. Plus 2 iota, that means coordinate is 0, 2. It lies here. The coordinate of this is 0, minus of 2, which lies outside this circle. Fine. So therefore this point is my lies outside, so only coordinate is my here. So I can substitute the value. What is the right answer of this? 2 pi iota times of, I can substitute value at 2 iota. I can substitute this value at here. So it is a 1 over 2 iota, that's a 4 iota square minus 4. This is my 4 iota. So 2 pi iota will be cancelled, 4 is cancelled, iota square minus 1. This is minus of 2 is the right answer of this problem. Look at this another one. Now again, center is 0, radius is my 4. Fine. Then the value of this. So we have to find the pole of this. Pole will be Z0 and cos Z0. What is the value of the cos Z0? It will be either pi by 2 minus pi by 2, then 3 pi by 2 and so on. But you can see that 3 pi by 2, 3 into 3.14 divided by 2, it's a 9, it's a 4 point something which lies outside of this. So this value will be cancelled. Pi by 2, 1.57, it lies here, it lies here. So therefore the poles are my Z is 0 plus pi by 2 and minus pi by 2. We can find the answer when Z is equal to 0. We can find the limit, or otherwise I can, because Z is equal to 0 here, so I can multiply this of the function. Find limit Z approaches. Whenever you take the limit, then you have to multiply this by the function. So what is that? Cos of 0 is 1. So the answer is 1. When you take Z is pi by 2, because the pi by 2 is not appears directly in this case, so we can apply the limit definition. So Z minus pi over 2 into 1 over Z into cos Z, which is my 0 by 0 form. So I can apply the L'Hopital rule. It's a 1 over Z minus sin Z plus cos Z. So what is the value when Z is pi by 2? This cos pi by 2 will be my 0, sin pi by 2 will be my 1. So its value is my minus 2 over pi. Similarly, what is the value when Z approaches minus 2 over pi? It is Z plus 2 over pi into Z cos Z. Again it's a 0 by 0 form. So this is my minus Z sin Z plus cos Z. So when it's a pi by 2, it's a pi over 2. Its value is again 0, it's a minus of 2 over pi. So what is the right answer of this? Iota times 4 minus pi, 2 pi iota, sum of the residues 1 minus 2 minus of 2, so that is my 1 and minus 4 over pi. So pi minus 4 will be cancelled out, it is then pi will be cancelled out, the numerator part becomes my this over pi. So it is a cancel out. 2 over pi is the right answer of this problem. You can pi is also cancel out, pi will also cancel out, so only the 2 is my right answer of this problem. Look at this another one. Again you can see a circle, radius 2, center is 0. Fine. Then the value of the I. Again you can see that denominator is a by 1. So you can find the pole corresponding to substitution of this value. So I can expand the cosine series. You know what is the cos of A? 1 minus A square by 2 factorial, A4 over 4 factorial, minus and so on. So this is 1 minus A square 1 over 2 Z raised to power 4 plus 4 factorial into power 4 Z raised to power 8 plus so on. Fine. So what is that? Clearly says Z is equal to 0 is my pole, because when Z is 0 it is my undefined, and Z is equal to 0 is the only pole which lies here. So it means what is the residue of the function at Z is equal to 0? We can find the coefficient of 1 over Z minus 0, or we can find the limit z approaches 0, z minus 0 into this function. Fine, that's on your choice. But whenever there is a series, you all knows what is the coefficient of 1 over z. You can see here it is 1 over 4 factorial. So what is the right answer of this? 2 pi iota times of 1 over 2 pi this. What is the residue of this function is 1 over 4 factorial. So what is the right answer of this? 1 over 24 is the correct answer of this problem. You can write in the decimal places if needed. Okay, C is the simple positive oriented circle of radius 2, center at the origin. Here we can draw the graph. 0, radius is my 2. Fine. Now then which of the following statement are my correct? Okay, firstly we can find the pole of this, because the denominator is nothing. So what is that? Z is equal to 0 is my pole, and which lies here. What is the pole of this? Again the denominator is nothing. So when this value will goes to the infinity, this value will goes to the infinity when z is equal to pi. Tan pi by 2 is infinity. Where is the pi? This is the pole. Fine. So what is the value of the pi is 3.14, and 3.14 lies outside of this. So this function is analytic. Answer of this will be the 0. What is the answer of this? What is the pole of this? Pole is my 1, 3, 3. But clearly says 3, 3, which lies again outside. This value will not be there. 1 is inside. Fine. So what is the pole of this? At z is equal to 0, I can find the coefficient of 1 over z minus 0. So I can expand this. What is the exponential series? 1 minus x plus 1 plus x plus x square by 2 and so on. What is the coefficient of this? So what is the residue at z is equal to 0? Can you find the coefficient of the 1 over z? So it is my 1 over 2 factorial. Fine. In this case, what is the residue at z is equal to 1? So because z is 1 here, I can substitute the value at this case. So 1 minus 3 square, 1 over 4. So what is the right answer of this? 2 pi iota times whatever the given to you, 2 over pi iota into residue of this 1 over 2 factorial is a 1 over 2. This value will be 0. This value will be 1 over 4. So can you get this answer? Pi iota will be cancelled out. It's a 4. What is the answer of this? It's a 3 over 4. So the right answer is my 3 is the correct answer. Just look at the graphical representation, find the pole quickly, get your answer in a very simple manner. Okay, now what is that? If I take the modulus, this value is my 1, it is my 4. It's a circle, center origin, radius 4, and it's a 0 to 2 pi. Fine. Again, what is the pole of this? Pole is my 0 and 2, because I can return this function as of this number. Fine. Now 0 is lies here, 2 is also lies here. So what is that? Residue at z is equal to 0. So I can write this function as of this nature. So it is e raised to power 0 over 0 minus 2 minus half. What is the residue at z is equal to 2? I can substitute at here. So e square over 2. So what is the right answer of this? 2 pi iota first residue plus second residue. So 2 will be cancelled out. Pi iota e square minus 1. Pi iota e square minus 1 is the right answer. Okay, f of z is my here, then gamma is, what is that? Mod of z is my 1. So it is circle with radius 1, center is 0. Okay, you can see whenever there is a f dash over f, we always apply the argument principle. Fine, that's quite easy. What is the argument principle is? F dash over f is nothing but number of the poles this is number of the zeros, p is the number of the poles of f. F is my here. What is the value of the f is z cube e raised to power z square. Can you find the pole? Because there is no denominator part, also the numerator part will not go to the 0, so number of the poles are my 0. What is the zeros? Because it's a cubic equation, so it has a 3. So what is the n minus p? 3 minus 0 is 3. But you can see the angle varies from the 0 to 4 pi. That means it rotates how many times? 2 times. So the right answer of this is 3 into 2. Or you can see it's a 3. So the right answer is 2 pi iota of 1 into 2 pi of this one. Fine. This is a one circle. One circle is my 3, but it's a 4 pi. So the right answer is 3 into 6. 3 into 2. This 2 is my 2 times rotation. Fine. Okay. F is a non-zero, is analytic at all the points of this. Then the value of the f, capital F is my pi f of cot I can written as cos pi z over sin pi z. Then the residue at the n, residue at z is equal to n. That's the meaning. So again a very simple, I can take the limit as z approaches n, z minus n of this function. Fine. Cos of pi z divided by sine of pi z. Now since function small f is analytic at here, so I can take pi, I can substitute z is my n which is outside, the rest part is my limit cos over sine into z minus n. Fine. Now clearly say it's my 0 over 0 form. So how you can do that? I can apply the L'Hopital rule. So f of n. So I can apply the L'Hopital rule. So first function is my cos pi z minus pi sine pi z into z minus n. Denominator will be pi cos of pi z. Now can you find the limit as z approaches n? This value will be 0. This value will be my 1 over pi. So this is pi f of n. Pi is also cancelled. F of n, B is the correct answer of this problem. Okay, look at this another one. What is that? I can return this number as of this. What is the meaning of that? It's a circle with radius 0, center 1. Center 0, radius 1. Then of this portion. Okay, again a very simple. Firstly, you can factorize it. What is the factorization of this? 2z minus 1 and z minus 2. Fine. I can make the coefficient of the z as a 1. I can take 1 over 2 as the outside. It is iota pi z over z minus half and z minus 2. Fine. Now we can find the pole. The pole is my half, pole is my 2. But you can see that 2 lies outside, so there is no pole. Half lies inside it. So what is the right answer of this? 2 pi iota times of this 1 over 2. Half is a pole. I can substitute the value of the half at here. Iota pi over 2. Half minus of this is a minus 3 over 2. So it's a 2 will be cancelled out. It's a pi iota. What is the E of this? It's a cos pi over 2 plus iota pi over 2. That's my iota divided by minus 3 over 2. It's a minus 2 over 3 pi. That's the value of alpha. But we need a greatest integer less than or equal to this. What is of this value? It's a 2 over 3 pi. So it's a 2 over 3 into 3.14. So 6.28 divided by 3. So it's a 2 point something. So greatest integer is my 2 is the right answer of this problem. Okay, look at this another one. Again, we can apply this argument principle. Fine. So this is n minus p. The function is my f. So that is f of z is my product of n is 1 z minus pi over n. That means it's a polynomial of degree 17. So clearly says that p will be my 0. There is, because polynomial has no pole in this. What is that? I can take z is e raised to power 2 iota t. That means this is my 1. So I can draw the circle, center 0, radius minus 1. Now can you find the zeros of this C? So what is that? If I open this, what will happen? It's a z minus pi, then z minus pi over 2, and so on. It will be z minus. So clearly says, what is the zeros is? Pi, pi over 2, pi over 3, pi over 4, and so on. The last number is my here. Is this number? Where is the pi? Is a 3.14, lies outside. Is a 1.57, is lies outside. It is my, is a 3.14 over 3, is a 1.0504. Again it lies outside. This is my divided by 4. It's a 0 point something. So it means how many poles are there? How many zeros are there? Total 17 apart from these 3. 14. Fine. So it is my 14 minus 0. So it is, so what is the right answer is 2 pi iota into 14 minus 0. That's my 28 pi iota. But now you can see it's a 2 iota t. Fine. Whenever t belongs to this value will 2 of t, which belongs to my 0, 4 pi. That means 2 times rotation. So I have to multiply this by 2 also. So it's a 56 of this. Then the value of the alpha. Now you can compare this. Value of the alpha is my 56. This 2 is again my 2 times rotation. Because here is my 2 iota t, and the t belongs to 0 to 2 pi. So the right answer is 56 is the correct answer. Okay, you can see I can return this z is my half e raised to power 3 pi iota t. What does it mean? It's a circle with center 0, radius half. Fine. And t is my 0 to 2. Whenever t is my 0 to 2, then 3 pi t is belongs to my 0 to 6 pi. How many rotations are there? How many rotations of 2 pi? That's a 3 times rotation. Then you can find this value here. Then 1 over z square e raised to power z minus 1. The pole 0, 0. The pole 0 is also the pole. Therefore 0 has 3 times pole. Order is my 3. So how you can find this? That means I can find either the coefficient way, fine, or you can take as a 2 factorial of z cube of this function. Either you can write like this way, find the second derivative of this, or otherwise we can expand it as a derivative way. We can find the residue like of coefficient of 1 over z. Look at that. I can expand this exponential series. What is the exponential series? 1 plus z square by 2 factorial and so on. So 1 will be cancelled out. Z plus z square over 2 factorial and so on. I can take z as a common. It's a z cube. So the rest part is my z over 2 factorial. Next part is z square over 3 factorial and so on raised to power minus 1. Now I can open this. What is the series of the 1 plus x of minus 1? 1 minus x plus x square and so on. So 1 z over 2 factorial, z square over 3 factorial square, and so on. Now what is the coefficient of 1 over z? Because it's a 1 over z raised to power cube, so I need a coefficient of z raised to power 4. So what is the coefficient? There is a term of z raised to power 4. The coefficient will be z raised to 2 will be 3, 4 will be my 2, 3, 4 and 5 factorial. So 1 over 5 factorial. Sorry, 1 over z. 1 over z is my z square coefficient. So 1 over 3 factorial. Fine, it's negative. Again from here, is there any term which involves the z square? Yes, the first term, it will be my 1 over 2 factorial square. So that is the right answer. 1 over 6, 1 over 2 square is 4. So what is the right answer of this is 1 over 12. Fine. So what is the right answer of this is 2 pi iota, residue is my 1 over 12 into 3 times. So what is that? 6, 1 over 2 pi. So what is the beta? Beta will be my 0.5 is the right answer of this problem. You can solve this problem here. You can find this as a 2 times derivative. You can find the 2 times derivative at the point z0 also. Okay, now look at this another one which is given to be here. Okay, 0, 1 pi is there, positive oriented of this. So x varies from 0 to 1, y varies from minus 11 pi here, and this value, it is 11 pi, it is minus 11 pi, this is x is equal to 1. So this is my area. Fine. Now can you find the pole of this? Can you find the pole of this? So the pole will be e raised to power 0. So z will be my log of 2. Fine. This is the way. But I will tell you the two methods. The first method, I can find the pole because numerator has no. So what is the answer of this is we can find the residue of this f at z is equal to log of 2. How you can find? I can find the limit z approaches log of 2, z minus log of 2 e raised to power z over here. Again it's a 0 by 0 form, so I can apply this derivative rule. So 1 into e raised to power z plus z minus of here divided by e raised to power z. So what is the answer of this? It will be 0. It is my 1. So the right answer of this problem will be my 2 pi iota into 1 over whatever the statement is given to you, this into 1. So the right answer is 1. Another way, there is a one more method that is quite easy for you. You can see this term is nothing but f dash over f. You can see if I consider this is my f derivative, this is my f dash, so I can apply the argument principle n minus p. What is the f is? E raised to power z minus p. Is there any pole of this f? There is no pole. How many zeros are there? How many zeros is only 1 when z is equal to log of 2. This is, so it's a 1. So 1 minus 0 is the here. So what is the right answer? Already 1 by 2 pi iota is written. So again 1 by 2 pi 1 is the right answer. Either you can find by using the residue. If you find it's by using the argument principle, again it's an easy target, you can solve it easy. So that's on your choice. Okay, now look at this another one. If you, again there are the two methods. Firstly, see the circle radius 2, center is origin. So it means this is my circle 2 and here. Now again I can easily see this is nothing but f dash over f. If I multiply and divide by 101, now it's f dash, so which is nothing but n minus p. So what is the f? F is z raised to power 101 plus 1. Clearly says there is no pole because it's a polynomial. How many zeros are there? zeros are my 1 0 1. So what is the n minus p is my 1 0 1. So what is the right answer of this? 2 pi iota times of this 1 0 1. What is the n minus p? 1 0 1. So what is that? 2 pi iota is the right answer. If you apply the simple argument principle, what is the second method is? Instead of this, how you can do? You can find the poles. What is that pole of this? It is 1 0 1 poles are there, and you can see it's a minus 1 omega 1 omega square up to minus 1 of this. These are my poles. Fine. Out of this pole, you have to look about how many are lies inside it. Then again you can see, you can find the residue, but I think that is a quite easy way whenever you find its derivative upside. Otherwise, if you look about here, so clearly says, if I look at here, this value is my plus 3 iota by 2 and minus half and root 3 by 2, where it lies inside it. This is also lies omega cube, you can check it and so on, but this is the best way you can solve. Okay, look at this another one. A function is given to be here, and this is a power series, look like say power series. Fine. How you can find the an? So we all know which is nothing but nth derivative at the center. Center is my 0. Fine. So nth derivative 0 of n factorial. So if we find the a6, this is my f. This is my f. You can find the sixth derivative. That's not an easy target for you. You can find the fifth derivative. Again, not an easy target for you. Then we can choose for the second method. How you can do the second method? I can return this function as of this nature, 1 minus z plus z square. Fine. Now I can open this summation part. How you can open that? This is z 1. Okay, what is the series of this? It is 1 plus x square plus x cube and so on. So 1 plus x square plus so on. Fine. Now how you can open this bracket? It's a very simple. It's a square, so I can do like of this 1 plus. I can open this as a binomial series. So it's a 2c say r. So what is that? ncr a raised to power r x raised to power n minus r. So a is my this, so that is z raised to power r. X will be my z square raised to power n minus r. So I can written this as z raised to power 2n minus r. So here is n is my 2, so it is my z raised to power 4 minus r. Similarly, the next part is my cube, so it's a 3cr z raised to power 6 minus r. Similarly, z raised to power 8 minus r and so on. Now look at that. Now your target is to find the a6. So if you look at that, if you compare them, a6 means coefficient of z raised to power 6, because 1z is already there. So I have to look for the coefficient of z raised to power 5 inside. So what is the coefficient of the z raised to power 5 inside? There is no term. Can be any term z raised to power 5? No, because it's a 4. Here, yes. For what value of the r? That is r is equal to 1. So this is my 3c1. Is there any term which involve z raised to power 5 when r is equal to 3? Fine. Is there any other term? So next term is ncr, that's a 5cr plus into z, it's a 4, 6, 8, 10 minus r. So can z, yes, when r is equal to 5. So 5c5. Rest of the term is no appear because it's a 6cr z raised to power 12 minus r. So for z raised to power 5, r must be 7, but 6c7 is not possible. So what is the answer of this? 4, 4, 1. So that is my 8. Similarly, we can find for the A5 means we have to find the coefficient of 5. So z is outside, z raised to power 4. So there is no term can be possible. Yes, when r is equal to 0. Is it possible? Yes, when r is equal to 2. Is it possible when z is power 4 when r is equal to 4? Is it possible when r is equal to 6? But 5c6 is not possible. So 2c0 is 1, 3c2 is my 3, 4c is my 5. So 3 plus 1 plus 1. So what is the right answer of A5 plus A6? It is my 13 is the right answer of this problem. So this is the way you can solve. You can see that we start from the 1996 paper question and ending at the 2023. And this is the way you can solve this residue and the complex integration solver in a very simple manner. We will see the next lecture on the basis and the dimension of this problem of the GATE 1996 to 23. I hope you can like, share and comment on my videos. Best of luck students. Happy learning.